Welcome back to your favorite pre-calc class. You guys are going to take a look at the laws of exponents. So here's our product rule. A to the m times a to the n is a to the m plus n, right? So for example, if you got 5 2's, like in this first one, I got 5 2's multiplied by 3 2's, 2 to the third. That would give us 8 2's, right? 2 to the eighth on that, or I think that's 256 if I'm not mistaken. Same thing for this one, 7 squared times 7 to the 8th, 7 to the 5th. As long as your base is the same, right? How many of those 7's do we have? We got 15 of those 7's. Go ahead and do that last one there. In fact, why don't you do the next two? The next one's got just a variable x for its base. Sure you check yourself on those two, and let's do this last one. We'll do it together. It looks like we have x to the 5th, x to the 7th, x to the 3rd, so x to the 15th, and we add all those up. Now this next one's called the power of a power rule, a to the m to the n. So for example, if you got 2 squared to the 3rd, what that means is I have 3 sets of 2 squared. I have 2 squared times another 2 squared times another 2 squared. In other words, I have 6 of them. So you can just multiply that 2 and the 3. Power of a power is where you multiply those. So 4 to the 6th to the 7th, just go ahead and multiply that. I mean, there's 42 of those 4's in total, right? Because I have 7 sets of 4 to the 6th. 7 sets of 4 to the 6th. That negative 3 to the 7th to the 3rd. All right, we're going to go ahead and multiply the 7 and the 3 there. Negative 3 to the 21. Go ahead and try that one. We got 8 to the 35 there. Yeah, good. 72. 110, 11 times 10. And this was called power of a product. So see how we have a power, nth power of the product a times b. So it's a to the n, b to the n. So it's kind of like if you had 2 times 3 to the squared, right? That's 6 squared or 36. But you can do 2 squared times 3 squared. Isn't 4 times 9 also? See how that's 36? Either way you do that. Right, so that's called power of a product there. So let's go ahead and do that on this. Negative 2 times x to the 8th. So you got negative 2 to the 8th, x to the 8th. So then you take negative 2 times negative 2 times negative 2 times negative 2 times negative 2, negative 2, negative 2, negative 2. I think I said that 8 times. And that'll give you a positive 256 x to the 8th. Similarly, for that negative 3x to the 4th, we're going to take that negative 3 to the 4th, x to the 4th, because we've got a power of a product there. So negative 3 times negative 3 times negative 3 times negative 3 is 81, positive 81, x to the 4th. Go ahead and try that one. Should get negative 64 x to the 3rd on that, right? Negative 4 times negative 4 times negative 4 is a negative 64. And let's do this last one before we get to the next rule. We have 2 to the 7th, x to the 3rd to the 7th, and finally y to the 7th. And so that 2 to the 7th, that'll give you 128. X to the 3rd to the 7th, that'll give you that 21 right there. And then, of course, we got y to the 7th on that. Well, the next one is anything to the 0 power is 1. In fact, sometimes I like to kind of show like an example to kind of show that, right? Whatever your base is. So like let's say, for example, you're dealing with a base 2 for a minute. Like for example, 2 to the 5th, we know 2 times 2 times 2 times 2 times 2 is 32. 2 to the 4th is 16. 2 to the 3rd is 8. 2 squared, 2 times 2 is 4. 2 to the 1st is just a 2. So what would 2 to the 0 be? Well, what are you doing each time to get from here to here? You notice that you're dividing by 2 each time, right? You're dividing Then you take the 16, you divide it by 2, and you get the 8. 8 divided by 2, and you get the 4. 4 divided by 2, and you get the 2. So 2 divided by 2 would be 1. Right? And you can do that with any base. You can do it a base 3 or a base 4 or so on. In fact, we could keep going with this. 2 to the negative 1 would be 1 divided by 2. 2 to the negative 2 would be a half divided by 2, which would be a fourth. 2 to the negative 3 would be a fourth divided by 2, or an eighth, right? 1 over 2 to the third, which is an eighth, and so on, right? Keep going with that. So, anyways, point being, anything to the 0 power is going to end up being 1, right? So 9 to the 0, of course, would be 1. That negative 17 to the 0 is going to be, and you got to be careful on this, because that negative means apply it at the end. This is how you want to think about that. I know there's no parentheses on that, but that's negative 1. This is different. Let me go ahead and write this. This would be different if I had negative 17 to the 0. Now that is just 1. That's different. You see the difference between the two? Got that negative out front of that. So you got to do that exponent first. You got to do the 17 to the 0 first, which is 1. Then you apply the negative out front. So be careful on that. 8 times x to the 0. Well, we know x to the 0 is 1, so we got 8 times 1, which is just 8. And finally, 5x to the 7th, all to the 0. Well, all that stuff is to the 0, so it's just 1. I'll let you try that. All right, check your work on that. You try a problem. Let's get to the quotient rule here of exponents, a to the m over a to the n. So this is kind of like 2 to the 5th over 2 squared, right? If you had 5 2's on top and 2 2's on the bottom, see how you're left with 2 to the 5 minus 2. You're left with 3 2's on top, right? 2 to the third. So 5 minus 2. So that's why we can subtract those exponents right there, which of course should be 2 times 2 times 2, which would be 8. So here we have 7 to the 10. We have 10 7's on top, 7 on the bottom. We're left with 3 7's on the top, which is 343 if I multiply 7 times 7 times 7. 6 to the 4, I have 4 6's on top, 1 on the bottom. I have 3 6's on top, which is 216. Next one, you can go ahead and pause the video if you need. 5 to the 9th over 5 to the 6th, so that'd be 5 to the 9 minus 6. That's really bad writing there, sorry about that. Going a few more here. We got w to the 21 over w to the 6. So we end up with w to the 15 when we multiply those. Or, I'm sorry, subtract those. And let's do some with multiple variables here. So I'm going to take my x's, x to the 150 minus 50, multiplied by my y's, 80 minus 30. So it looks like I have x to the 100, y to the 50 on that. And you can't simplify that anymore. I'll let you try that one. You should get w to the 23 on that one. And now we've got a power of a quotient. Power of a quotient. So a to the n over b to the n is our rule here. So this 12/5 squared can be written as 12 squared over 5 squared. So 144 over 5 times 5 is 25. This can be written as 1 to the 5th over 3 to the 5th. Or 1 times 1 times 1 times 1 times 1, and 3 to the 5th. So 3 times 3 times 3 times 3 times 3 would give us 243. This next one, we've got a negative, but we've got something to the 0 power, right? So that 7/19 to the 0. If you want, you can write a 7 to the 0 over 19 to the 0. Either way, it's 1 over 1. So that just ends up being 1, right? Anything to the 0 is 1. But then we apply that negative out front. So I got negative 1. Here we've got the 6 being squared, x to the 3rd is being squared, we've got the 7 squared, and then we got the y to the 5th being squared. So it looks like we end up with 36 x to the 6 over 49 y to the 10th. And you can go ahead and try that last one. Should end up with 64 x to the 18th over 27 y to the 27th. So much for taking notes. See you next time.